All right, everybody. So for today's video, we'll be learning about two more types of graphs that we can use to discover patterns in raw data. The first of which is called a frequency polygon, and then the other one is called an ogive. Okay. So you'll have to excuse the stat cat today. The stat cat has just eaten lunch. That explains the fishbone. But what we're going to do is we're going to use some examples that I've already showed you in some previous videos. Okay, so we don't have to start anything from scratch here. I can just make some, very slight changes to some things we've already done, and it'll be real easy to show you what both of these things are as a result. Okay, now one quick note. Up to this video, once this video is done, here's all the different kinds of statistical graphs we will have learned about. First one was the frequency histogram, then the relative frequency histogram, and then now the frequency polygon and the ogive. And so you could wonder why so many, why can't we just stick with just one, and so on and so forth. And we can give a short and a long answer to this, but let's give the short answer. Let's think, what is the purpose of drawing a graph? Well, one, you could say people are visual, and so sometimes, rather than just seeing a bunch of numbers, they might rather see a picture. But I guess a little bit deeper than that, graphs help us discover patterns in data. I mean, ultimately, that's what we want to do. Just having a bunch of assorted numbers doesn't really teach us very much about what the world is like. If I want to know what iguanas are really like, and I take a bunch of measurements, say if I'm an ecologist or something, those numbers on their own don't really show me anything, okay? So what the graphs do is help us see patterns in the data, okay? All right, now if that's ultimately one of our goals, one type of graph might be better at doing that than another. Okay, so that's how, one reason why we have so many. It's a fairly basic reason why we have so many. Okay, all right, so yeah, I did say that, well, I didn't say, the StatCat said we're going to use some examples from earlier videos to learn about a frequency polygon and an ogive. And maybe you remember this example. Remember I said that suppose there's an ecologist and he's out in the wild and he measures the lengths in centimeters of 24 iguanas, okay? And this is the raw data. Remember, the raw data is just kind of a mess. It's hard to see much from the raw data. Maybe at a glance I can say, well, they look like they're between like 50 and maybe 70 centimeters in length, okay? But beyond that, I can't really tell much at a glance from the raw data. Now, what we had done with this in the other video was make a frequency distribution. And that's what the graphs are based on, okay? So here's the frequency distribution that I made from the raw data. All right, so here's the raw data. I separated it into 5 classes, okay? And I tallied the frequency for each class. So what these numbers mean is that, for example, for iguanas between 57 and 61 centimeters in length, there were 6 of them in the whole of the data, okay? That's what frequency means. In cumulative frequency, you could think of that as like so far. And here's what I mean. Or up to a point. I could say, well, that 18 right there means that of iguanas between 52 centimeters in length and 66 centimeters in length, there's 18, all right? So that's the total so far once you get up to the measurement of 66 centimeters in length. And to find these numbers, you just say, well, there's 3 here in that class, and there's 6 here in this class. Well, there's 9 so far up to that point of 61 centimeters in length, okay? Now, the short story is that, oh, also the midpoint. What's the midpoint? The midpoint of the class is just what it sounds like. It's the middle. How did we say we found the midpoint? Well, it's the middle, and, maybe it's obvious enough for you that 54 is right in the middle of 52 and 56. But the way that you find the midpoint of each class is you take the first, lower class limit, and you add the upper class limit, and then you divide by 2. So if you take 52 plus 56, and then you divide by 2, you get 54, okay? And then all of these are separated by the class width. All right, the class width here is 5. Now, but a lot of that is stuff that I talked about in earlier videos. But we use the midpoint to make the frequency polygon. Okay, that's why the midpoint was part of some of the frequency distributions that I made before. Even though we hadn't used it at that time, I did include it in my frequency distribution. But we use the midpoint to make the frequency polygon, and we use the cumulative frequency to make the ogive, all right? But let me show you how. Now, this right here is the finished product for the frequency polygon. This is what it is, okay? And what I do here is I start at 0. We always start these at 0. And we always end them at 0, okay? And we connect the frequencies 3, 6, 9, 5, and 1, 3, 6, 9, 5, and 1 with a straight line. All right, I just got the ruler, connected each data point, each frequency with a straight line. The reason we do that is because if you were to look at a frequency histogram, they're real blocky, and we might think that, of the iguanas between 56.5 centimeters in length and 61.5, there's probably a continuous spread where they're going up and down. It's not like, there were, of all iguanas between 61.5 and 66.5, that there were just, whatever that number is, 9 right there. If you measured a bunch of iguanas, it's probably just like they followed this rough pattern, but individually their measurements kind of went up and down like that as a curve or a line or something like that. So that's one of the thoughts behind what a frequency polygon is. But here's what we do. Okay. So I said use the midpoints, okay? But we want to start at 0 and we want to end at 0. That's the nature of the frequency polygon, right? Because you think at the extremes there are 0. There might be 3 between 52 and 56, but, you think if you got far enough below that, there wouldn't be any. And, there might be 1 between 72 and 76, but if you went far enough above that, there'd probably be 0, okay? So, yes, we have the midpoints. Look at this, 54, 59, 64, 69, 74. Those are all on here, but I go 1 class width to the right and 1 class width to the left. So in other words, you might see a pattern here that all of these midpoints are separated by 5, right? 54 plus 5 is 59, plus 5 is 64. So if there was a midpoint that's left or under this one, it would be by subtracting 5, okay? So that would make it 49. So that's 1 class width to the left, and that one will be at 0 for reasons I said, right? Because if you go far enough, under 52, under that class, then you're going to have none. And then I went 1 class width to the right. So what's this, 74? What's 74 plus 5? Remember, all these midpoints are separated by 5. 74 plus 5 is 79. Now, but otherwise, all you see here are for the midpoint 54, for this class, the frequency is 3. So I put a dot at 3. And then for 59, the frequency is 6. And so I put a dot at 6. And then I connected them with straight lines, and that's a frequency polygon. One thing that I realized I didn't mention in the other videos is, you see this jagged, this zigzag right here? That means that we're like skipping some of the axis. Because you see this is 49, and then that's 5 more at 54. But think it would be awkward to count from, what is this number right here? What's this first number on the vertical axis or the horizontal axis? Right there, what is that number? That's 0. So it'd be a little bit awkward to count all the way over to 49. So this zigzag right there is just a symbol or a notation that means that we skipped part of that and we're starting at 49, because it would be awkward to draw the whole thing, okay? All right, so there's your frequency polygon. That's what you do for that. Now let's look at the ogive. The ogive uses the cumulative frequency, okay? But it also uses the class boundaries. Now, real quick, before we get into that, what's the difference between the class limits and the class boundaries? Well, okay, so the deal is, see how there's these gaps in the classes? So 52 to 56 centimeters. So this represents iguanas lengths between 52 and 56 centimeters. And then this class is 57 centimeters to 61, but there's this gap. This one ends at 56 and that one starts at 57. What about the numbers in between? Well, the class boundaries take care of that. We just give ourselves a little room to the right and a little room to the left and a little room to the right. Okay? Now, the class limits, 52, 56, 57, 61, those being whole numbers, we just subtract from 0.5 to get the lower class boundary, that's this number, and we add 0.5 to get the upper class boundary. And notice how this one leaves off now where this one picks up. Okay, this is kind of a fine detail. It might be something that you really don't care about, who knows, but that's the way they do it. This makes it continuous in such that there wouldn't really be gaps in the data or the classes. Okay, so that's the difference between the classes and the class limits and the class boundaries. Now, we still tally the frequencies the same. It's still true that between 51.5 centimeters and 56.5 centimeters, there were 3 iguanas in that class. And we still tally the cumulative frequencies the same way too. Now the stat cat has to tell us that when we make an ogive, we use the class boundaries and the cumulative frequency, okay? So the ogive is a cumulative frequency graph. It lets us tell how, what the frequencies are up to that point or so far as you go through the data, all right? Okay, so here's what we're going to do. We always start with the lower class boundary, okay? 51.5, all right. And that would be 0. Wouldn't the cumulative frequency be 0? I mean, the smallest data entry is 52. So up to the point of 51.5 centimeters, there aren't any iguanas that have that length so far. There are none up to that point. So the ogive will always start at 0, okay? But beyond that, I can say 56.5. How many iguanas have a length up to 56.5 centimeters? Oh, that would be 3. And then I go to 61.5, okay? So how many iguanas have a length up to 61.5? Or if you're tallying the lengths so far to 61.5, how many iguanas would have that length? Well, that would be 9, all right? So see, 9, and then the next one after that is 18, and then 23, and then 24. Now, as far as patterns go, like, I started the video by saying the point of the graph was to try to discover patterns in the data, and I can see what it seems that like the biggest rise in the number of iguanas happens in here, okay? Like, not so much at the beginning. We're not, as we go up to 56.5 or 61.5, then, we're not finding that many iguanas that have lengths up to 61.5. But then here, there's a fairly big jump. And then notice in here, the jump doesn't seem to go up as much. So if I go from 66.5 to 76.5, I'm not finding that many iguanas that have that length, okay? So that's the way that I can see a pattern in the ogive. All right, now, real quick, oh, sorry, when I made this, I just did not do a very good job making the vertical scale, okay? But, I'm drawing these by hand because I think it's a good way to do it in the video. And I take my time and I try to make them neat for you. But, truth is, if you have a Texas Instruments graphing calculator, it will make many of these statistical graphs for you. You just have to put the data in. I don't happen to own a graphing calculator, so I can't show you. But if you use Excel or if you use StatCrunch in my math lab, you can also use those to generate these statistical graphs for you also. Okay, but I'm drawing them by hand because I think in addition to using technology, it's not a bad thing to know how the technology is doing what it does. Okay, now one other real quick thing. So remember, we're trying to find patterns in the data. When you see this and you say, okay, well, this is telling me the number of iguanas that have whatever length in centimeters, what do you see there? So, well, it looks like most of the iguanas that were measured are in the middle, okay? And I said that, that's normally true with things you measure about people or animals, as most people are average or a little bit above average or a little bit below average. Very few people or animals are significantly above average or significantly below. That's just the way it tends to work out with most things that you measure with people and animals, okay? So, I can see that fairly easily in this frequency polygon, and that would be one of the objectives in having one in the first place. Now, isn't that better and more instructive than me just showing you these numbers and saying, what does it look like iguanas were like? Tell me, just stare at the numbers and tell me what you see. Most people are not going to see very much. But, here, I think we can see a pattern fairly easily.